So, how to make a box and whisker chart manually? Maybe I should back up. You got a data set, you're trying to get a feel for it. You'd like to summarize it in some fashion. Identify the highlights of it. Most of classical statistical methods are really computationally intensive. You need a computer. You can't do it by hand, really. You shouldn't do it by hand. That even a calculator, you're likely to make some type of an error. But so why would we do things manually? Well, there are some approaches that are very simple that date back to when computers were as big as a small house. And we still wanted to get a good sense of what a data set looked like. And one of the devices was one developed by a statistician, a very smart man, John Tukey. And he was particularly interested in how to summarize a data set and how to do it visually, that we can see so much in terms of that. He had a quote, something to the effect that numerical measures that you get summarize their descriptive statistics that tell you what you expected to see. Visual techniques are ones that show you what you didn't expect to see. So let's see, what are the important things? With any data set, the most important piece is probably where the middle is. What's the average? What's the center? Who is typical? But as a single number, it's too compact. We'd like to know where is the middle group. So maybe the middle 50%. And then there's some that are below that 50% and some above. But where is that center group clustered? And are they bunched close together? Are they quite diverse, that middle group? Then among the low ones, the bottom, say 25%, what would be a really low value? I don't mean the really crazy outliers, because there's often some strange ones in there. But what would be very, very low? So what does that bottom 25% look like? And then what does the top 25% look like? Again, let's keep those strange people to the side. And so what sort of pattern do we have overall as to the low people, the ones in the middle, the high people? And then if we do have some strange ones, who are they? What do they look like? So let's do this, and we'll do it with a relatively modest data set. We're going to use this data set, 50 values. These are actual values. They came from a survey done some years ago of a first-year group of students, asked them how much they expected to earn when they graduated. And here, just for 50 of those individuals. To summarize 50 numbers, typically in working out averages and other statistics, is a lot of work. But let's do it without calculators and fancy math. I've got a bunch of numbers. Looking at the pattern in here, hard to see. First thing Tukey would suggest is sort the data, smallest to largest. So let's do that. So I've got my data sorted here. And then I look to see, well, where's the middle? Seems to be in the center here, around 50,000. Well, the measure of the middle we're going to use is the median. And the median is known as being 50%, are smaller, and 50% are larger. I've got 50 values, so this would be about the 25th value. I've got 25th from where? 25. Here's 10, 20, 1, 2, 3, 4, 5. There's my 25th value. Let me highlight them. Okay. But I could have counted from the other end, 10, 20, 21, 22, 23, 24, 25. Oh, so there are two values that are sort of in the middle. In this data set, they're both the same. They're 50. It's going to be, in this instance, $50,000. If the numbers were different, I would have averaged the two. So that's middle. Now, what would be the bottom quarter, the top quarter? So this is like slicing a pizza. I've sliced it in half. Now slice it, each half in half. So here I've got 25 values. There's 20, and then the other 5 here for 25. Halfway through there, so the middle of the first 25 is the 20.5 value, something along those lines. We call that the first quartile. I'm splitting my data into 4 chunks. So we're splitting it into 4 quarters, and this is the first quartile. So with that, I would count, here's 10, 11, 12, 12 and a half would probably be like number 13. So that's the middle. Or I could have counted, remember I counted before from the end. So I could go 5, 6, 7, 8, 9, 10, 11, 12. 12 and a half is still going to give me 30,000. So my value that I've got here for the first quartile is going to be $30,000. So that I would view as being a very low expectation, not a super low, but that's the low end of the middle. And then the middle, oops, of the last 25 is the 12 and a half from the end. So that would be counting backwards. There's 10, 11, 12, 13. Or I could have counted from 50. There's 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. And this one is known as the third quartile. And I'm saying here that that's going to be $65,000. Those give me a sense of about half my data is between 30 and 65. About a quarter of it is below 30,000. About a quarter of it is above 65,000. But the middle is that 30 to 65. And usually that's the most important group for us. We'd like to know who is in the middle. If I was to do it graphically, I'd draw a little picture like this. So I'm drawing it on a vertical basis. That's the way Excel does it. In the past, when we did this before Excel and did it manually, we'd do it horizontally, and I'll show that in a minute. But if I was to do it like that, I'm just doing it within Excel to draw. You can do this by hand. I'm going to put a box, and my box is going to go, there's 60, 65, so let me start at about here, and I'm going to go down to 30. Okay, and that's the middle 50% of my data. Now, we could zoom a little bit closer here, and I should draw in where the median is, the middle of this. My middle of my data set is at 50, and whoops, I think I've gone too far. Excuse me. 50 is here, and you can't see that. So let me change its color and make it brighter or bigger. There, now you can see it. This box here, though, I drew this wrong spot. 30 starts at about here. Okay. So it's reasonably symmetrical around the middle of 50, and I've got 65 on the upside and 30 on the bottom side, so $15,000 gap here and $20,000 gap there. It's reasonably symmetrical. And this is the middle of my data set. I might want to label it. Let me just put some descriptors in here so that I remember what things are. So this piece up here, I've called the third quartile because the last quarter is above it. And that's the spot right up here at the top end. And right in the middle here, I've got the median. And that's right there. And down here, I've got my first quartile. Oops, where'd you go here? That was this guy right here. And most of the time, this is the most important part of my data set that I've got. But then what about the bottom group and what about the top group? And how am I going to define what's really low, what's really high? So let me go back here. I need to know, to be able to get a sense of what's low and what's high, I have to have a sense of how spread out my data is. This is just something that we'll use along the way. Oh, by the way, if you were curious as to why I've got first quartile and third, but where's the second? The median is the second quartile. I have a quarter of my data between 0 and 30,000, a quarter of it between 30 and 50, a quarter between 50 and 65, and a quarter between 65 and the end. So now my spread of my data, we're going to define that in terms of the interquartile range, or so we'll just write it IQR. That's simply equal to the third quartile minus the first quartile. It's a simple measure of spread that I don't need a calculator to work out. Okay, so in this instance, I would have that being 65. Oops. And I'm going to subtract the 30,000. So it's equal to $35,000. There's nothing magical about the number. Don't read too much into it. It's just an idea of how spread out the data is. And we use that to define references as to what low and what high is. We're going to talk of low and high. In my picture, I'm going to use actual data values, not just some calculation. But I'm going to start out by defining a fence. I'm going to build a fence. I'm going to call my low fence, which is equal to my first quartile, my definition of low, minus 1.5 times this IQR. Okay. So in this instance, that's going to be taking 30,000 minus 1.5 times 35,000. Some of you may need a calculator to work this out. Back in John Tukey's time, everybody was good at mental arithmetic and could do these sorts of things in their head. And I think this is going to be minus 22,500. Crazy number. It's negative. We couldn't have a negative salary. But I am going to define very low as being equal to the last value inside the fence. So in this case, fence, I just want to put it in, oops, excuse me, just as a line here, it's going to be sitting way up here. So it's negative actually, but to be inside the fence, the last value inside the fence is going to be that smallest number, 2,000. That is going to be my very low. And that at the same time, how do I define very high? I'm going to make a high fence around the highest value. It's going to be the same way going out the other direction. The third quartile plus 1.5 times IQR. And you do the math, you should get 117,500. And so my value for very high is going to be the last value inside, which in this instance is going to be, if I put that line in, that fence is going to be somewhere in here. So the last value inside is going to be equal to 100,000. That's going to be my value for very high. If I put this all into a picture, it looks like this. So if I go in here and I'm going to put a line here that's going to go from 2,000, somewhere around there, up. Yeah, it's a little bit crooked. Way over there. How about that? And we'll pretty it up, make it thicker so we can see it. So this is the bottom 25%. And I can go and make the top 25% on the top end. It's going to go up as far as 100, a little bit stretched out, a little bit more than the other one is. Okay. And this summarizes then most of my data. It's sort of balanced here on the two sides. I do have a couple of strange values though. I've got one sitting here just outside at 120,000. And I've got another that is sitting at 175,000 way up here. And I've got another one sitting way up at 200,000. So those are my outliers. These ones up here are outlier values. I should be focusing my attention here, not being too distracted by these ones way up at the top there. That's my box and whisker diagram. It's relatively simple. Do it by hand. The hardest part is sorting your data. Sorting by hand, you can probably do up to 100 or 200 values easily in just a few minutes. And then sketch out this type of thing. And it's a quick summary of a data set. And they're really useful when we're comparing several groups, as we'll look at later. In the old days, my days, we did it horizontally. We'd just flip it around so it looks like this. And so you might think of it as being similar to if I had a histogram, presuming you've seen a histogram before, that would look, say, along the lines of this thing, where here is the middle chunk of my data. I've got some spread on the bottom end, some on the top end, and I've got a couple of odd ones scattered out here. So maybe here is a somewhat of a bell-shaped curve, but I've got a long tail to the right. Instead of going through all of the work you have to do with histograms or these other types of charts, which have a lot of, they're busy looking. This is very busy. And this is really, really simple. It just says the middle guys are here. Pay attention to them. But these are the low earners at graduation. These are the ones that think they're going to have high earnings at graduation. And these people are on drugs or something. They're totally crazy to earn such high salaries at graduating from an undergraduate degree. But so be it. And that's it. That's your box and whisker chart. Hope you liked it. Bye.